So when we look at any element on the periodic table, let's say carbon, for instance, okay, we know that that number stands for the atomic number. That's the number of protons. That number never changes. It's the identity of every um, element on the periodic table. And that number right there, that's the atomic mass. And that's the number of neutrons, which are neutrally charged, plus protons. And we learned last class that this number here, that's also equal to the electrons in its neutral form, but it's not equal to the electrons in its ion form. And this number here is not an even number because isotopes of elements exist, meaning elements that have differing number of neutrons. Protons wouldn't change because it wouldn't be the element anymore. And what you see here is the weighted average. So mostly carbon has 6 protons and 6 neutrons. But sometimes carbon has an isotope of 7 neutrons. Very rarely, though. That's why the average is closer to 12 than 13. And I like to use a certain format for doing these problems. That's counting the particles. And let's go ahead and look at that. I like to use a format that looks like this. We're going to take barium here. Okay. So first off, we'll do the barium. And then I put the atomic mass here. So barium 137, and let's do the atom. And let's go ahead and up here do the protons, neutrons, electrons, and then we'll do the symbol. Okay. Might be slightly different than what you have in your handbook, but that's totally okay. And let's take a look at that. We'll do a few of them as we go through this. Here. Okay, let's do what we can do very quickly. Barium has 56 protons, and when it's in its atom form, that means it's neutral. So it also has 56 electrons, and 137 is the protons plus the neutrons. So 137 minus 56. That's 81, and that is the number of neutrons. And the symbol here is just going to be Ba. We assume it's got a neutral charge. Okay? So let's do another one here. Let's do the barium 137, but let's do the ion instead. Again, it's barium. Whether it's an atom or an ion, it's going to have 56 protons. Its atomic mass is 137, so it's going to have 81 neutrons. But we know here that barium would like to be like xenon, and it's going to have to lose 2 electrons to do that. So this number is going to go down to 54. We see that 56 minus 54 is plus 2. So the barium ion, and everybody in this row, the alkaline earth metals, is 2 plus. I don't know why in chemistry they say 2 plus instead of plus 2, but whatever. Let's do one more just for the heck of it. Let's do the nitrogen. And nitrogen, let's do the 15 atom. So nitrogen has an atomic number of 7. When it's an atom, the electrons is also 7. And 15 minus 7 is 8. So nitrogen in its neutral form is just N. Now, interestingly, when we take any of these non-metals, if we were to do the ions of them, you'll notice that we change this ending here to "ide." So if we did the nitride 15 atom, it would still have 17 of these. It would have 8 of those because 7 plus 8 is 15. But nitrogen here in its ion form is trying to be like neon. It's going to gain 3 electrons to have 10 electrons with an overall negative 3 charge.